Welcome back, dear friends. I hope you have mastered the previous material very well. Today we'll talk about the non-classical measures of position. So then, sit back and listen carefully. We have known the classical measures of position, which are arithmetic mean, geometric mean, and harmonic mean. Now, we can move on to the non-classical measures of position. Non-classical measures of position are quite different than the classical ones. They have different construction, they have different interpretation, and they may be used alternatively with respect to the classical measures of position. Among the non-classical measures of position, we can distinguish mode and group of measures called quantiles, in which we have what? Median, quartiles, quintiles, deciles, and percentiles. We start with the first, our subject of interest, mode. The mode is very simple and also very interesting measure of position. It can be successfully used beside the classical measures of position. It can constitute an additional information in our research about the typical characteristic level of considered phenomenon. Here we have an intuitive definition of the mode. The mode of a qualitative. Yes, it is qualitative because it may be used in the case of qualitative variables. The mode of a qualitative or quantitative variable is the value of the variable that occurs most frequently in a statistical series. In other words, it means that this is the value that appears the most often in a statistical series. Graph. This graph presents an example of the unimodal statistical series in which we have the percentage of the students that are characterized by a particular grade from the, for example, final test from statistics course. And what can we perceive here? We can notice that the highest percentage of students are characterized by the grade 4. So it means that grade 4 appears in the statistical series the most often. So 4 grade is our mode here. Sometimes in the statistical series we can find more than a single mode. That situation is presented in the figures below. On the left side we have the example of 2 modes, so it means that we deal with a bimodal statistical series. Here we have 2 values, around 20 and around 35. We have here 2 values that appear with the highest frequency in the statistical series, and this frequency is equal in both cases. On the right side, we have the example of multimodal statistical series in which we have 3 modes, 4 modes, and more modes. This case also contains the situation when all the values of our attribute are different. For example, 1, 3, 4, 6, 10, 11, 16. This is an example of a multimodal statistical series. There is no a single mode here, so it has a multimodal character. Let's make a first example based on individual series and related to a point frequency distribution series. Business and finance management student has collected the data on 5 variables. XI, total points of teams from statistical Premier League table. YI, key call content in 100 grams of products consumed today. ZI, air temperature measured in the following days at the top of the mountain mean. GI, grades from statistics course in business and finance management group. And CI, eye color of business and finance management group members. Let's see the data. Here we have first statistical series that is related to total points of teams from statistical Premier League table, and as you can see, 9 and 22 appear the most often. Appear with the highest frequency, which equals 2. So in this statistical series we have 2 modes. We can write it down using mode simple MO, and here we have 2 modes, 9 and 22. In the case of the second statistical series, key call content in 100 grams of products consumed today, we can't distinguish any single mode here, so this is a good example of multimodal statistical series. There is no single mode there. Here it's easy to find a mode which is, of course, 0. 0 appears here 3 times, so our mode here is 0 Celsius degrees. So this is a predominant feature of the temperature. Here we have related to a point series, grades from statistics course in business and finance management group, and what kind of information we can find in the table. We see that the most numerous group of students are characterized by grade 3.5. So grade 3.5 appears with the highest frequency. It occurs most often, most frequently. So 3.5, 3.5 is definitely our mode here. And the last one, the example based on qualitative variable, eye color, we see that brown color is a predominant feature in business and finance management group members. So our mode is brown. Our considerations become more complicated when we start working with the interval series. As you know, in the interval series, we don't have any detailed information about the multiplicity of the occurrences of the particular variable values. The only things that we have are the intervals of the variable values. For this reason, we only know that a mode is hidden somewhere between the lower bound of the first class and the higher bound of the last class. Otherwise, it means that the mode is somewhere between minimum and maximum value. Our task is to find an appropriate class, the mode class. How to find it? It's very easy. When we use the frequency in our distribution series, the class of mode is that class which are characterized by the highest value of the frequency. In the situation where we work with the relative frequency, the mode class is that class with the highest value of the relative frequency. Let's find here, in this simple example, the class of the mode. So mode is hidden in the class which is characterized by the highest value of the frequency. Here, the highest value of the frequency we have in fourth class. So this class is the mode class. It's our level 0 in our formula. So this is the mode class. I'm sure that mode is somewhere between 41 and 50 because this is the most numerous class, yes, in which we have the most numerous statistical units belonging to this class. How to compute mode here? Mode is equal to x0 is the lower bound of the mode class, n0 is the frequency of the mode class, n-1 indicates -1 level. Here we have level -1. It means the previous level, the previous class. So n-1 is 45, the frequency from the previous class. here we have also n0, and another category that appears in this formula is n plus 1. Here we have plus 1 level. So it indicates the class that goes after the mode class. So n plus 1 is 31, the frequency from the next class. And here we have also C0 category. C0 is the difference between the upper bound of mode class and the lower bound of the mode class. C0 is also called the range of the class. So here the range of mode class is 9 because it is a consequence of subtracting 41 from 50. 50 minus 41. The range is equal 9 here. Alright, we know how to calculate the mode working with the frequencies. So let's do it. Mode here, mode of age is equal to x0, lower bound of the mode class, 41, plus n0 is the frequency from the mode class, 62, minus n minus 1 is the frequency from the previous class, 45, divided by 2 n0s, 2 multiplied by 62, minus 45, n minus 1, and minus n plus 1, the frequency from the next class, 31. This fraction is multiplied by C0, the range of mode class, which is 9. This is the difference between 50 and 41. And the final result is following. I'm using calculator here. First, I'm trying to calculate the denominator. The denominator here, 62, 1, okay. Saving the result in the memory of the calculator. Multiplied by 9 plus 41, and the final result is 44.188 years. 44.188 years. What does it mean? It means that the most common age in this population is around 44 years. This is the example of the interpretation of the mode. Okay. And I will show you how to compute the mode using relative frequencies here. So let's move the table to the left side and we are able to do the calculations once again, but now using relative frequencies. Here mode is equal to, here we have the column with relative frequencies. We know that the mode class is the fourth class, and the lower bound of mode class is 41 plus F0. I remind you that we use the relative frequencies currently. F0 is relative frequency from the mode class, 0.363, minus F minus 1 is the relative frequency from the previous class, that preceding the mode class, 0.263. 2 F0, yeah, minus 0.263. Here F minus 1 is repeated, and minus F plus 1, this is the relative frequency from the next class, 0.181, and the whole fraction is multiplied by C0 range of the mode class. And then the final result is about 44.191 years. I suppose that you have noticed that here we have a little bit different result from the previous one. Here the question arises, why do we have a different result here? Where do the differences come from? The answer is the differences are due to the applied approximation in the relative frequency column. As you know, we applied here approximation of 3 places after a dot. We don't care about the values that go after the third place. We know that we are inaccurate here. We accept that fact. And in statistics, this is a normal situation. We know that the differences between the results are the consequence of the applied approximation. It's okay, so don't worry if you have a little bit different result, because this is the case of applied approximation. Let's make an example based on the real data. The table contains the information about the COVID-19 death distribution for Italy case and Spain case. Data comes from May 2020. Our aim is to compute, estimate and interpret the mode age of the COVID-19 victims on the basis on the real statistics, and knowing that the oldest victim of the virus was 107 years old. You can check it out. Here you have appropriate links. Let's start with the mode age of COVID-19 victim in Italy. Mode Here IT indicates that we are trying to compute the mode age for Italy case is equal to, in the first step we must find the class of the mode for Italy. It means that we are looking for the most numerous class. As you can see, the most numerous class here for Italy is the 6th class. So hence this is our 0 level, the class of the mode. We know that mode is equal to the lower bound of the mode class plus, here we have frequencies, so we apply here the formula based on the frequencies, n0 minus n minus 1 to n0s minus n minus 1. You know, the frequency from the -1 level, it means the class that goes before the mode class, minus n plus 1. This is the frequency from the class that goes after the mode class, multiplied by C0, the range of the class. In our example we have what? X0 is 80. This is the lower bound of 0 level class, the lower bound of the mode class, plus n0 is 12,387 minus n minus 1 is 8,347. We have two n0s. We repeat 8,337 and minus the frequency from the next class, 5,015, and the whole fraction is multiplied by the difference between upper band and the lower band of the mode class, which is of course 9. And the final result is, you can check it out, the final result is about 83.191 years. So the most common age of COVID-19 victim in Italy is about 83 years. 83 years. We can do the same thing for Spain. And the whole process starts again. The most numerous class is the same, the 6th class, yeah, for Spain. And then we have the lower bound of the mode class, which is the same, 80 plus n0 here is 7,872 minus n minus 1, the frequency from the previous class that preceding the mode class, 4, 6, 3, 2. We repeat the values from the nominator and minus 482 multiplied by 9, and the final result is very similar to the previous one, 84.148. As you can see, as you can see, the most common age of COVID-19 victim in Spain is a little bit higher than the most common age of COVID-19 victim in Italy, and it's around 84 years. In the next example, we are the financial analysts, and we are trying to calculate and interpret the most occurring level of the compensation. In the insurance company, you will never receive your money back. Here we have an appropriate data about the compensations. This is our variable. Here we have the intervals of the values of considered variable, and we know that compensations are divided into two groups: domestic compensations and foreign compensations. Using the frequencies, we express the domestic compensations. Using relative frequencies, we express the phenomenon of foreign compensations. Two different presentations of the data. And let's start calculating the most common compensation for domestic customers. Mode domestic, mode of the compensation. In the first step, we are looking for the most numerous class, which is the second class, so it means this is our zero level, the mode class, in which we have x0 is the lower bound of the mode class. See, x0 is 2.1 plus, as you remember, n0 is the frequency from the mode class 101 minus the frequency that comes from the previous class 63 divided by 2 n0s minus n minus 1 minus finally 17, the frequency from the next class 17, multiplied by the range of that class. The range of that class is a difference between 3 and 2.1. Of course, it's 0.9. And we can move on to the proper calculations. I try to compute the denominator to multiply the 1.1 minus 63 minus 17 and 101 minus 63. Alright, multiplied by 0.9 plus 2.1, and the final result is about 2.380, and the unit of our variable is 1000 euros. And the final conclusion is the most accurate level of the compensation for domestic customers is about 2.38,000 euros. Please write it down. This is the important content of the calculation, the interpretation of the final results. Alright, now we can compute the mode for the foreign customers. In the first step, we are trying to locate the highest, the class with the highest value of relative frequency. And this is the third class here. So third class is the mode class for the foreign customers. X0, yeah, we can repeat the whole formula for the relative frequencies. X0 plus F0 minus F minus 1, 2 F0s minus F minus 1 minus F plus 1 multiplied by C0. In our example, we have X0 3.1 plus F0 0.256 minus F minus 1 0.211 divided by 2 F0s F minus 1 and F plus 1, which is 0.196. Everything is multiplied by 0.9, the range of that class, and the final result is following. Multiplied by 0.9 plus 3.1, and the final result is about 3.486 thousand euros. and the interpretation is following. Of course, we see that the most common compensation for the foreign customers is approximately equal to 3.486 thousand euros. And the last one, how do you interpret N2, of course, for domestic customers, this is the second frequency. The second frequency is 101, and it means that 101 domestic customers are characterized by the paid compensations from 3.1 to from 2.1 to $3,000. Once again, 101 domestic customers are characterized by the paid compensation from 2.1 to 3,000 euros. Thank you very much. Very well. Currently, we know how to compute classical measures of position, and we know how to compute and interpret mode as well. Mode is an example of non-classical measures of position. Now we can describe another group of non-classical measures of position in which we have median, quartiles, quintiles, deciles, and percentiles. We start our considerations with the median. The median is the basic non-classical measure of position. In contrast to the arithmetic mean, it doesn't take into an account all the values of the variable. It takes care of the middle value only. In opposite to the arithmetic mean, it rejects other values of the variable. The median divides the population into two halves. In the first half, 50% of the population is characterized by the variable value not higher than the median, and in the second half, 50% of the population is characterized by the variable value not lower than the median. Let's imagine following situation. Here we have the example of a small firm which counts 10 workers, 10 employees, and we can characterize these workers by the monthly salaries. And first person, for example, earns $800 per month. The next one, 1,000, the third, and so on, 1,000, 200, 1,000, 300, 1,000, 500, 1,000, 600, 1,000, 700, 2,000, and finally 5,000. Yeah? As you can see, I have ordered the observations in non-descending way. Let's try to find the median. Here we have 10 observations. So it means that the median, which indicates the half of the population, lays exactly in the middle of the population, because this is the middle value and 50% of the rank numbers are above and 50% are below the median. So here we have the median. Median in our example is the arithmetic mean of 1,300 and 1,500. We add 1,300 and 1,500 and divide the sum by 2. It's of course $1,400. This is our mean. And this is our median. What does it mean? It means that the half of the workers, the half of the population, earn not more than $1,400 per month, and another half of the population, another half of the employees earn not less than $1,400. This is our middle value, and it takes into consideration only two values. Okay, I want to show you the difference between the arithmetic mean and the median. In our example, median is 1,400. Mean, arithmetic mean of the monthly salaries are 800 plus 1,000 plus 1,000 plus 1,200, 1,300, 1,500, 1,600, 1,700, 2,000, and the boss. The boss is characterized by 5,000. And the sum of all values of the variable is 17,100 divided by 10 gives us arithmetic mean $1,710. Yeah, and we see that mean is higher than the median. Yeah, and both measures are the measures of position. Both measures indicate the typical level of considered phenomenon. Okay, we know this situation. Let's assume that the boss, here we have the boss. The boss wants to earn $10,000. Yeah, he's the boss, so he can rise his salary to $10,000. So, oh, what happened? now it's okay. Sorry for a technical problem. Let's come back to our example. As I said before, boss wanted to earn 2 times more than in the previous situation. He wants to raise his salary from $5,000 up to $10,000. In the previous situation, arithmetic mean was 1,710. In the new situation, in which boss earns $10,000, mean is about $2,210. And what about the new median here? The new median is also equal to 1,400. Nothing changed here, yeah? So the main conclusion is that the median is more resistant to the extreme high or extreme low observations. Yeah, here the boss overestimated the typical level of the salaries of the firm. Yeah, here the more appropriate value that indicates a typical level of monthly salary is our median. Is more accurate in my opinion. It fits well to the empirical data. We need a special guide that will help us in finding the median. As we know, the median is the middle number in a sorted list of values in non-ascending or non-descending way. This is the value that lies exactly in the middle in the statistical series. If we work on an individual series, so all the values of the variable are known, we use the following formulas. If the population size is odd, 3, 5, 7, 9 and so on, the subscript which indicates the position of the median value is following: n plus 1 divided by 2. For example, the population size is odd and it is 5. So we can distinguish x1, x2, x3, x4 and x5. For example, 7, 9, 11, 13 and 19. And then which value is the middle value? This example is very simple. Median is that value which is characterized by the subscript n plus 1, 5 plus 1 divided by 2. So this is x3. x3 is our median, is the middle value. So here we have the median. But if the population size is even, 2, 4, 6, 8, and so on, we use this kind of formula. Let's change our example. Now we deal with the population size equal to 6. And we should add here an extra number, x6, which is 30, for example. And let's find the median in the new situation. We deal with the even numbers, so median here is equal to x with subscript n divided by 2. X, now n is equal to 6. 6 divided by 2 is x3 plus the next x is n divided by 2. 6 divided by 2 yields 3 plus 1. Finally we have 4 divided by 2. So median here is the arithmetic mean of x3 and x4. In our example is 11 plus 13 divided by 2, so this is 12. 12 is our median. It lies exactly in the middle of the individual series. We can also say that the half of the population, the half of the values, 50% of the values, are characterized by the value not higher than 12. 11 is not higher than 12, 9 is not higher than 12, and 7 is not higher than 12. And another 50% of the values are not lower than 12. 13 is not lower than 12, 19 is not lower than 12, and 30 is not lower than 12. Beside the middle point, the middle value, we can also indicate other positions in the statistical series. For example, here we have 25% of the population, which is characterized by the lowest values of our variable. Here we have the last 25% of the population, which is characterized by the highest values of our variable. Hence, I'm talking about the quartiles, the example of non-classical measures of position, another example of the quantiles groups. Quartiles should be associated with dividing something by 4. First quartile, it means 1 quarter. 1 divided by 4, 25% of the population. Yeah. 3 quarters means 3 divided by 4. 75% of the population, or the last 25% of the population. 2 quarters means 2 divided by 4, the half of the population. So the second quartile contains the same information as the median. The interpretation of the quartiles are following. First quartile gives us following information. 25% of the population is characterized by the variable value not higher than the first quartile. First quartile divides the population into 2 parts. First, 25% of the population, and the last 75% of the population. So we can also use another sentence. 75% of the population is characterized by the variable value not lower than the first quartile. Here we have values not higher than the first quartile. Here we have the values not lower than the first quartile. Third, let's talk about the third quartile. It means that 75% of the population is characterized by the variable value not higher than the third quartile. Simultaneously, 25% of the population is characterized by the variable value not lower than the third quartile. Not lower than the third quartile. So, third quartile divides the population into 2 parts. First, 75% of the population, and the last 25% of the population, which is characterized by the highest values of considered variable. And remember that first quartile is not higher than the second quartile, which is the median, and it's not higher than the third quartile, because we are talking about ordered non-ascending or non-descending way individual series. Let's back to the first example. We can also find here a first quartile and the third quartile. You know, we have analyzed the monthly salaries in a certain firm, and we see that 25% of the employees are characterized by the monthly salaries not higher than the first quartile here. And here we can also indicate the last group of 25% of the employees that are characterized by the monthly salaries not lower than the highest salaries, the 25% of the highest salaries in the firm. Okay, and now the instruction how to find quartiles in the individual series. It seems to be complicated, but it's really not complicated, it's very simple. First quartile is described by the following formulas. The center of interest is that fraction in which we have the population size. If the result of n plus 1 divided by 4 is an integer number, the situation is very simple. For example, n is 11. Okay, so this fraction will be 11 plus 1 divided by 4. It's 12 by 4, so it's 3. It means that the first quartile is the x with the subscript of 3, x3. And the whole process is finished. But if this fraction is not an integer number, we use this kind of formula. For example, n is 12, so the fraction is 12 plus 1 divided by 4, 13 by 4, and this is 3.25. It's not an integer number. So, first quartile here will be x with the subscript, which is rounded down the closest lower integer here. Rounded down, the closest integer here is, of course, 3. So here we have x3 plus here we have the value of non-integer 3.25 minus the rounded integer 3, and here in bracket we have x rounded down integer 3 plus 1 is 4 plus minus x3. Yeah, rounded integer 3 plus 1 4 minus rounded integer 3. And that's all. The process for the third quartile is exactly the same. It's similar, it's analogous. So that's all for now. Alright, we are able to solve the first task connected with the median, the first and the third quartile. Here we have the well-known example. Business and finance management student has collected the data on 3 variables. XI, total points of teams from a statistical Premier League table, Kickel content in 100 gram of products, and air temperature measured in the following days at the top of the mountain mean. Based on the data from the next slide, please find and interpret median, first quartile and third quartile. Here we have an appropriate table. Let's start with XI variable. In the first step, we should indicate the population size. The population size for XI variable is 11. 11, of course, is an odd number. How do we find the median here? Median. We use the appropriate formula. X with subscript, the position of the median will be n plus 1 divided by 2. It means that we have here x with the subscript 11 plus 1 divided by 2. 11 plus 1 is 12 divided by 2 is 6. X6 is our median. 1, 2, 3, 4, 5, 6. 15. 15 points is our median. Please write down the interpretation. 50% of teams are characterized by the number of points not higher than, not greater than 15 points, and another 50% of teams are characterized by the variable value not lower than 15 points. Alright, let's compute the same thing for yi variable, quartile content. Like earlier, we have what? The indication of the population size. Here, the population size is 10. So we are dealing with the even number. How to compute the median here? Median here is equal to y, because our variable has y symbol. Yes, we denote this variable by using y. Y with n divided by 2 plus y with the subscript of n divided by 2 plus 1. And we divide this sum by 2. In our example, the sum is following: y n by 2 over 2, 10 divided by 2 is 5. So we can write it down: y5 plus 5 plus 1, it means y6 divided by 2. And we have what? y5, 1, 2, 3, 4, 5, it's 91. y6 is the next number, 105 divided by 2. So here we have 196 over 2. So this fraction is equal to 98. Check it out. Of course, quartile. The interpretation of this measure is following. Please write it down. Here we have the median, which is 98, and the interpretation. And the interpretation is following. 50% of the products are characterized by the quartile content not higher than 98%, and 50% of the products are characterized by the quartile content not lower than 98 quartiles. This is the interpretation. How about the variable z? It's your part. Z is especially dedicated for you, okay? I will give you the final results. And now, let's compute the first quartile. Okay, the second command tells to calculate the first quartile. We know the population size of the x variable, and we know the population size of y variable. The start point is to calculate the fraction of n plus 1 divided by 4. And we should answer the question if it is an integer or not. Here we have 11 plus 1 divided by 4, 12 by 4, and this is 3, so this is an integer number. So the calculation of the first quartile is very easy. This is third value in ordered statistical series. In our example, third value is 9 points. So the interpretation of this amount, of this measure, is following. Please write it down in this manner. 25% of teams are characterized by the number of points not higher than 9 points, and simultaneously the rest of 75% of teams are characterized by the number of points not lower than 9 points. Let's back to the yi variable. The central point of our interest is the fraction of n plus 1 divided by 4. In our example, it's 10 plus 1 divided by 4, 11 by 4 is exactly 2.75. And as the formula suggests, we should to round down this fraction to the closest lower integer, because 2.75 it's a non-integer value. It should be rounded down to the closest lower integer. The closest lower integer is 2. So we can start our calculations. Here we have the first quartile of the y variable values, in which we have y with subscript rounded down value to the lower integer, 2, plus difference between the non-integer value and rounded down integer value, and here we have the difference between y3 and y2 values. Check it out. Compare this with our formula. y2 is 65 plus 0.75 multiplied by the difference between x3, 66, minus 65. And finally we have 65 plus 0.75, because this difference is exactly equal to 1. Consider the first quartile value is 65.75 kcals. Please write down the interpretation. Here we have first quartile 65.75. This is the first quartile of kcal content values. It means that what? 25% of the products are characterized by the kcal content not higher, not greater than 65.75, and simultaneously the rest of 75% of the products are characterized by the kcal content value not lower than 65.75 kcals. And finally, we are able to compute the third quartile of following variable values. In the case of variable x, in the first step we compute the appropriate fraction 3 multiplied by the bracket n plus 1 divided by 4, and here we have 3 multiplied by 12 divided by 4, and it's 36 divided by 4. It yields 9. So the situation is very simple. This is an integer number, so the third quartile of discussed variable is x with the subscript of 9. It's 9th value of variable x. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the third quartile of the points from the statistics Premier League. It's 20 points. We focus on the second type of the interpretation, which indicates 25% of teams with the highest score in the table. We highlight this group and we can say that this is the interpretation of this amount. Please write it down. 25% of teams are characterized by the number of points not lower than 20 points, or 25% of teams with the highest score are characterized by the number of points not lower than 20 points. Okay, we can back to the variable y, in which the fraction of 3 multiplied by n plus 1 divided by 4 is equal to 33 divided by 4, and this is 8.25. 8.25. This is a non-integer value, so we round down this non-integer number to the lower closest integer, which is 8. Okay, and we can start appropriate computations. The third quartile of y variable values is equal to y8 plus the difference between the non-integer and integer value, 8.25 minus 8. Yeah, and here we have the difference between 9th value and 8th value. Okay, in our example we have y8 is 111 plus 0.25, this is the difference between non-integer and integer, multiplied by y9 is 132 minus y8, 111. Finally, we have 111 plus 0.25 multiplied by how many? 20 22. 22 by 0.25 plus 111 is 116.5 kcals. What does it mean? The interpretation of this measure is, here we have third quartile, which is 116.5 kcals. 25% of the products are characterized by the kcal content value not lower than 116.5 kcals. And of course, we know that, but this is not very important information, but we can say that the rest of 75% of the products are characterized by the kcal content not greater than 116.5.